Okay, so ang topic natin ngayon is medical gas and vacuum system. So, ito yung medical gas application sa hospital. So, dito tayo mag-concentrate sa medical gas piping system through pendant. Ito yung mga outlet. So, ito yung mga bed head units. Andiyan na covered yung mga outlet sa bed. Ito yung equipment. So, magka-separate siya. Yung suction pump sa compressor. Nitrocaustic cylinder, tapos ito yung mga bulk tank, oxygen. So, meron din namang manifold type. Yan, ito yung mga commonly used medical gases in hospital. Meron tayong oxygen, nitrous oxide, medical air, 400 kilopascal or 4 megapascal or 4 bar, which is ME4, or medical air 700 kilopascal or 7 bar, ME7, which is surgical air. So ito yung common na medical air is yung 4 bar lang. Okay? And PSI, later malaman sa yung yan. So ito naman is surgical air or SA. Okay, ito yung mga pang tools. Yan. So carbon dioxide, special application to. Nitrogen, so nagpapalitan lang itong medical air 700 kilopascal sa nitrogen kasi both siya sa instrument. Then medical vacuum, ito yung sa pasyente equipment. So type of healthcare facilities, meron tayong hospital, nursing home, medical and dental offices, and clinics. These facilities fall into two general categories, the short-term and long-term care. Short-term is considered the typical acute care, surgical, or medical type hospital. So hospital is defined as a building or part thereof that is used for medical, obstetrical, psychiatric, or surgical care on a 24-hour basis for 4 or more patients. These include general hospital, mental hospital, tuberculosis hospital, children's hospital, etc., etc., and any facility providing inpatient care. Nursing homes. Nursing homes is a facility providing long-term nursing care and housing on 24-hour basis for patients who because of physical or mental incapacity may be unable to provide for their own needs without the assistance of another person. This type of facility includes nursing and convalescent facilities, skilled nursing homes, intermediate care facilities, and infirmities with homes for the aged. Next, limited care facilities. A limited care facility is used on 24-hour basis for the housing and care of 4 or more persons who are incapable of self-preservation due to illness, accident, mental retardation, or chemical dependency. Then other healthcare facilities, other healthcare facilities or portion thereof provide diagnostic and treatment services to patients other than those provided in hospitals, nursing homes, and limited care facilities. This category is intended to encompass all other facilities without the need for specifically naming them, which in the past has resulted in misinterpretation and misapplication of standard. It includes small outpatient facilities and medical and dental offices. For the design, healthcare is in constant state of change, which forces the design engineer to keep up with new technologies to provide innovative approaches to the design of medical gas system. In designing medical gas and vacuum system, the goal is to provide a safe and sufficient flow at the required pressure to the medical gas outlet or inlet terminal served. System design and layout should allow convenient access by the medical staff to outlet and inlet terminals, valves, and equipment during patient care or emergencies. So these are the rooms ng mga chemical. So oxygen backup, sabihin secondary, malapit dun sa merong mga ganyan sa ibang lugar. So kasi meron tayong main supply. Okay? ICU, nurse, hospitalization, NICU, recovery, OR, so yun tayo doktor para sa mga i-define pa natin yung mga yan. Stable lang tayo mag-depend. So, AGSS, air system, so ito yung compressed air, ito yung vacuum. So, isang room tong mga nitrous oxide and oxygen. So, dapat nga isang room talaga to. Hindi pwede siyang lumapit dito. O, basta may boundary ka, may protection. Kasi yung pump, yung compressor, may heat yan. So, mag-heat ito, di ba? So, medical gas design checklist. As in any hospital facility, must be specially designed to meet the applicable local code requirements and the healthcare need of the community it serves. So the medical gas and vacuum piping system almost must be designed to meet the specific need of each hospital. So following are the essential area of the healthcare facility. To determine, analyze its area, a specific area of the healthcare facility to determine the following items. A, which pipe medical gas system are required? Kasi hindi lahat yan gusto nung ng hospital. So, meron ang isang katamihan lang is oxygen, medical air, yan. So yung iba, so optional na lang yung mga room. Panglinis ng tools, pero pwede siyang nitrogen, pwede siyang surgical air. Okay? May minimum requirements naman yan. Kasi hindi kaya ng budget. B, how many of each different type of medical gas outlet and any terminals are required? Kung may gusto na yung hospital management na ganito sa mga rooms, so hindi nyo lang sa kanila. So pag wala, meron tayong lecture mamaya ng mga table. So that is mga requirements. C, where should the outlet and inlet terminals be located for maximum efficiency and convenience? D, which type and style of outlet in the terminal best meet the need for the medical staff? To B, anticipate any building expansion and in which direction the expansion will take place, vertically or horizontally. So determine how the medical gas system should be sized and bound to accommodate the future expansion. So yung piping yan, mga abang. At C, determine location for the various medical gas supply sources. So bulk oxygen, high pressure cylinder manifold, oxygen, nitrogen oxide, or nitrogen, oxygen, vacuum pumps, medical air compressor. So ang tawag yan is yung plant room kung saka manifold room. So prepare the schematic piping layout locating the following. A, sound valves. B, isolation valves. C, master alarm. D, alarm. E, calculate the anticipated peak demand for each medical gas system. Appropriately size each particular section to avoid exceeding the maximum pressure drop allowed. F, size and select the various medical gas and vacuum supply equipment that will handle the peak demand for each system, including future expansion. If this project is an addition to an existing facility, determine the following. A, what medical gases are currently provided and what are the location and number of stations para tali na. So B, can the current gas supplier or hospital purchasing department furnish the consumption records? C, are the capacities of the existing medical gas supply system adequate to handle the additional demand? D, are any existing system that could be used for an extension? Are the existing pipe sizes adequate to handle the anticipated additional load? Okay. E, what type of equipment is in use and who is the manufacturer? Is this equipment state of the art? So F, is it feasible to manifold the new and existing equipment? G, what is the physical condition of the existing equipment? H, is adequate space available for the new medical gas supply system and related equipment at the existing location? I, is existing equipment should scheduled to be replaced? So a maintenance history of the existing equipment may help in this determination. So number of station. The first step is to locate and count the outlets and inlets, often called stations. So yan, yung mga rooms. Station yung per bed. So meron yan sa dalawa. Yeah. This is usually done by consulting a program prepared by the facility planner or architect. Kung walang program, yan nga, may table dyan. Lagay natin lahat. Kailangan. Okay? Wala naman sila sinabi. This program is a list of all the rooms and areas in the facility and the services that are required in each. If a program has not been prepared, the floor plan for the proposed facility shall be used. So no code specifically mandates the exact number of stations that must be provided in various areas or rooms for all healthcare facilities. So in fact, there is no clear consensus of opinion among medical authorities or design professionals as to how many stations are actually required in the facility areas. Guidelines are published by the American Institute of Architects, AIA, National Fire Protection Association, NFPA, and American Society of Plumbing Engineers, ASPE, that recommends the minimum number of stations for various services in a specific area. So the most often used recommendations for determining the number of stations for hospital are those necessary to be accredited by the Joint Commission. So accreditation is required for Medicare and Medicaid compensation. The Joint Commission publishes a manual that refers to the EIA guidelines for minimum number of stations for oxygen, medical air, and vacuum that must be installed to obtain accreditation. If this is a factor for the facility, these requirements are mandatory. Other jurisdictions, such as state or local authorities, may require plans to be approved by local health or building official. This approval may require adhering to the state or local requirements and or NFPA 99, Standard for Healthcare Facilities. Okay. Kung i-apply niya, so kailangan magsunod sila doon sa standard requirements. So marami pang hospital na hindi sumusunod. So, di ba, oxygen lang. Yung oxygen, portable. Sa mga lilit na hospital. So, dapat required sila. If accreditation or the approval of a tourist is not a factor, the number of area and area of location of stations are not mandated. The actual count will depend on the requirements determined by each individual facility or another member of the design team using both past experience and anticipated future use. Often, using this guideline recommendation as a starting point. So, table 1 provides this recommendation. So, dito yung room, column. So, dito naman yung oxygen, vacuum, nitrogen oxide, air, nitrogen, and vacuum. E-vac. Basta, yan. So, sa patient room, for example, isang room, meron kang isa. So, isang outlet para sa oxygen sa isang patient. Okay? This is typical use is patient care. Pharma room, drug preparation, so isang vacuum, isang air, number of outlets to. Standard lab use. Laboratory. So, minsan hindi na require. Physiology, lab general is 1. Standard lab use plus teaching. Premature nursery, obstetrician, so dalawa. Isang vacuum, so yan. Dito lahat yan. Recovery rooms, dalawang outlet na kailangan. 3. This is recovery beds, ha? So, sa higaan. Yan. Dalawa, tatlo. So, pag isang patient, ito lang. Ito sa beds na to. Yan. Per bed. Andyan yung mga typical uses. Treatment note, tig-isang per room. So, per bed na yan. Standard X3. So, dito lahat yung mga value kung ilan sa ospital. So, kung wala dito, yung hinahanap mo, hanap ka ng pinakamalapit. Yeah. So, next is, ito yung station ng mga outlet. So, pag nalihat mo na yung outlet, diba, ilolocate mo na sa room, sa babaw ng bed, determine, sample naman tayo. So, ano naman yung mga flow rate? So, ito, medical gas flow rate. Aha. So, all medical gas, each station must provide a minimum flow rate for the proper functioning of connected equipment under design in emergency condition. So, the flow, makita yung page. Natakpan yung page. Yung page na to. Okay. Na. So, the flow rates and diversity factor vary for individual stations in each system depending on the total number of outlets and type of care provided. The type of care and yung area. Table 2. This is the medical gas. This is now for medical air. Okay? The flow rate from the number of counts without regard of any diversity is called the total connected load. Parang sa ilaw, puro yan, bawa, for 10 watts, parang kuryente. Total niya, 10, 100. Pero hindi man siya magkasabay-sabay kung iba-ibang room. Okay? So it's called the total connected load. If the total connected load were used for sizing purposes, the result will be a vastly oversized design since not all of the stations in the facility will be used at the same time. A diversity or simultaneous use factor is used to allow for the fact that not all of the stations will be used at once. It is used to reduce the system flow rate in conjunction with the total connected load for sizing mains and runs piping to all parts of the distribution system. So, meron tayo sa table ng simultaneous use factor. So the factor varies for different areas throughout any facility. So the estimated flow rate and diversity factor for various system area station pieces of equipment are found in tables 2, 3, 4. So yeah, this is so tabulation pag-compute ng capacity no compressor sabi sa air. Yeah. So ito yon. So kahit ilan siya, isa lang, multiply mo siya ng 100%. Surgery, major surgery, so ilan yun. So this is pre-air design flow rate, ECFM. So alam niyo naman itong ECFM, di ba? Standard cubic feet per minute based on standard atmosphere condition. Okay? This is different from actual. So ang actual is kung ano ang pressure, so mag-iiba yung flow rate mo. Di ba? Ideal gas lang yan. So, ayan, 0.5, 0.5. So, gamit natin to sa pag-size ng compressor. Okay, hindi natin na-explain isa-isa. Level 3, marunong naman kayo na magbasa, di ba? Outlet rating chart for medical vacuum piping system. So, ayan. This is now for vacuum. Okay. So, ito yung peak chart, medical surgical vacuum naman to. Is kung available yan, kung dito siya, 3.5, 3.5, di ba? Pag ito kinuha mo, 2, medium B, 10. Kahit isa niyan, multiply mo siya ng 100. Okay? Delivery rooms, andyan lahat. So, ang bawa ito, emergency room, yun yan, 100 pa rin. So, ito, surgical room, medical room. So, lagay mo per outlet. Yan yung outlet mo, 10. Kahit isang outlet lang yan, multiply mo pa rin siya ng 0.1 times 0.1. That is diversity pa rin yan. Okay? Mga tanong kung bakit gagamitin naman din na bakit 0.1 na. May mga considered na may mga kasama yan sa system. Ha? Yan solo. Pag alam mong solong-solo talaga, di 100%. Now, the total demand for medical gas system varies as a function of time of day, month, patient care requirement, and facility type. The number of stations needed for patient care is subjected and cannot be qualified based on physical measurement. Knowing the types of patient care and or authority requirement will allow placement of station and usage group. These groups can establish demand and simultaneous factor diversities, which are used in the calculation for sizing a particular system. All medical piping system must be clearly identified using an approved color coding system similar to that shown in Table 5. So, dito tayo sa US color, mayroong oxygen green, carbon dioxide gray, mercury oxide blue, cyclopropane orange, helium brown, nitrogen black, air yellow, vacuum white. Okay? So, gas mixture other than oxygen and nitrogen. So, ayan yung color niya. Color marking of mixture shall be combination of color corresponding to its component gas. So, and the rest, yun yan, from CGA. So, ilalagay nyo to sa piping. Yan. So, color-coded ng piping, matagal na rin dinidiscuss yan, di ba? Okay. So, medical gas dispensing system. So, yan, mga outlet. Most manufacturer of medical gas system equipment offers various type of medical gas outlet. Ito yung mga outlet yan. Yan. So, the medical gas outlet are available in various gas order. So, may pasunod-sunod pa yan. Oxygen, nitrogen, air. The center line spacing and for exposed and concealed mounting. Outlet types and configuration must meet the requirements of the local jurisdictional authority and NFPA 99. All outlets must be properly identified and confirmed. Care should also be taken to accurately coordinate the various species of medical gas spacing equipment with the architect and medical staff involved in the project. If the project is a renovation, the outlet type should match existing requirement. With fabricated patient head wall units, the medical gas outlet are generally furnished by the equipment manufacturer, and it is very important to maintain coordination to avoid unnecessary duplication of work. Over-the-bed medical gas service consoles are often specified in the electrical or equipment section of the specification. And medical gas service outlet are specified, furnished, and installed under the mechanical contract. Yeah. So, sequence. Hindi niya pwedeng hindi on order kasi malilito yung nurse. Doktor, nurse lang. Gas outlet sequence, central line spacing, and multiple gang service outlet are some of the consideration to be taken into account when requesting information from the various equipment manufacturer. It is more practical in terms of both the cost of the equipment and the installation to specify and select the manufacturer's standard outlets. Details and the specification regarding the individual standard outlet are usually available from all manufacturers upon request. Huwag kayo maya mag-request. The existing outlets are compatible with adapters found on the hospital anesthesia machine, flow rates, vacuum regulators, etc. Care should be taken to make sure all future expansion in the same facility have compatible equipment. So, pwede mag-request sa mga manufacturer kamaya kung kayo ang kausap. Pero kung iba naman kausap doon, siya ang sabihan mo mag-request siya. Pag di ka binigyan, sa problema niya yun. Siya ang taga-request doon, siya ang kausap. So, patient headwell system. So, a recent and growing trend in hospital construction is the requirement for patient headwall system, which incorporate many services for the patient care. Kanya lahat yan, yung mga medical gas outlet, electrical service outlet, including emergency power, direct and indirect lighting. Sana, di ba? The lights, nurse call system, isolation transformer, and grounding outlet, G, patient monitoring receptacle, its vacuum slide, and four the brackets, and night lights, the electrical switches. Bed locator units are also available, which serves to provide power for more advanced patient bed. telephone light, and standard power. These units also function to protect the wall from damage as bed are moved and adjust. So, yan. Okay? Ito mga gandang hospital. Makita ka sana dito sa atin. Yan. Okay? Yung sa loob ng hospital, ito ang maganda. Hindi yung sa labas. Okay? So, head walls currently vary in shape, size, type, and cost from the simple over the patient bed standard configuration to elaborate total wall outlet units. Most manufacturers of medical gas equipment offer medical gas outlet for all types of patient consumption available in today's market. When specifying head wall outlet, the plumbing engineer should consider the following. A. Is the service outlet selected compatible with the existing outlet component? B. Does the patient head wall manufacturer include the type of medical gas outlet required as part of the product? Yeah. So a special type of ceiling mounted medical gas outlet. Ayaw ng ano sa wall, sa kisame. Saan ba madalas gamit ito? Kung meron kang sa gitna, mga center, marami yung ano mo, pero sa gitna, mga higaan sa gitna. So, saan ka lalagay? So, dyan, wall, ceiling mounted. In critical care areas, which are generally considered by the most individual to be those locations of hospital providing a special treatment or service for the patient, such as surgery, recovery, coronary, or intensive care unit. The designer selection and placement of the medical gas service equipment must be done very carefully to provide efficient work center around the patient for the medical staff. Manufacturers of medical gas service equipment usually provide a wide range of equipment that is available for use in this area, depending on the customer's preference and available budget. The equipment is selected to provide the necessary individual gas services and accessories. Ano yan? Table 6 provides a quick reference guide for the engineer to use as a basis for selecting the commonly used type of outlet dispensing unit. Ito yung table 6, and ito yung hospital area, autopsy room, and then yung well-mounted outlet, patient care head wall, ceiling mounted outlet with host staff, rigid ceiling columns, yung mga type. Okay. So, autopsy room, dalawa lang ang possible, delivery rooms, ito. So, ayan yung iba. Emergency operating room, yan, well-mounted and nitrogen control cabinets. So, ito yung mga equipment, major surgery, dami. Ayan. Ito yung mga types ng dispensing equipment recommended. Okay. High pressure nitrogen dispensing equipment. Dito siya. Okay. A special consideration must be given by the plumbing engineer to the placement of nitrogen outlet. So the primary use of nitrogen gas in hospital is for the driving turbosurgical instrument. Variation of this turbosurgical instrument in both their manufacture and intended use will require several different nitrogen gas pressure level to be available. For this reason, it is necessary for the engineer to provide an adjustable pressure regulating device near the nitrogen gas outlet. A nitrogen control panel is usually located on the wall in the surgery room opposite the operating area exterior field. The installation should allow for the access and adjustment of pressure setting by a surgical nurse. Ito. Yeah. Kahit hindi kayo doktor, hindi kayo nag-medical, makakakabasa doon yung mga equipment. So piping from the nitrogen control panel to a surgical ceiling outlet will provide a convenient source of nitrogen for surgical tools. This will prevent hoses from being located on the floor or between the wall outlet and the operating table. Excess hose can be obstructive to the surgical team. Next, medical gas storage. Pause muna tayo. So, medical gas storage, ang nakikita dyan is yung manifold room, saka yung tangke, sa labas to. Isa naman hatiin to, andyan yung mga compressors, kalahati niyan. Okay. After deciding the medical gas services to be provided at the facility, the engineer should determine the storage capacity and pipe sizing required and possible location for the service. Local codes and references as well as the administrative authority having jurisdiction should be consulted for its medical system. Because of the unique characteristic of its medical gas source, the gases are described separately in this section, this topic. Also, an explanation of the techniques currently employed to exhaust anesthetic gases is provided. So figure 1 illustrates a typical layout of liquid oxygen emergency reserve supply equal to 1 day supply. Cylinder, nitrous oxide, and cylinder nitrogen supply. Yung mga reserve, depende sa gusto ng client yan. Pero pwede ka mag-equal. Maximum is siyempre same size. Okay, equal. Ang iba naman recommended is 1 day supply sa oxygen. So oxygen. Several factors must be known when estimating the monthly consumption of oxygen in new or existing healthcare facilities. A, the type of medical care provided. B, number of oxygen outlet or number of patient bed. C, future expansion of facility. D, approximate consumption in existing facilities. So two methods can be used by the plumbing engineer to estimate the consumption of oxygen. The more accurate method is to obtain a detailed consumption record from the healthcare facility or monthly oxygen shipment invoices from the suppliers, lalo sa may existing. If inventory records are not available from the healthcare facility or the supplier, use consumption record from a comparably sized facility with good judgment. Yan, oxygen. Ay, ito. So the second method is to apply the following rules of thumb to estimate the monthly supply of oxygen. So the estimating method should be used with good judgment. Always coordinate estimated demand with the oxygen supplier during the design process. In non-acute care area, allow 500 cubic feet, 14 cubic meter per bed per month for supply and reserve oxygen. B, in acute care areas, allow 1,000 cubic feet per bed per month for supply and reserve oxygen. Okay. Oxygen supplies sources are divided into two categories: bulk oxygen system and cylinder manifold supply system. Bulk oxygen system should be considered for healthcare facilities with an estimated monthly demand more than 35,000 cubic feet 1991 or equal to 70 oxygen outlet. Manifold system are used in small general hospital or clinics. This is the demand. Okay. So bulk oxygen system. When selecting and placing oxygen, several factors must be considered. Oxygen transport truck size, truck access to bulk oxygen tank, storage tank, and NFA 50 standard for bulk oxygen system at consumer sites. Bulk oxygen equipment, construction, installation, and location must comply with NFA 50 recommendation. If liquid oxygen is spilled to leak, an extreme fire or explosive hazard could occur. NFA has designed standard to minimize fire exposure to and from structure. The location of bulk oxygen storage tank and equipment must be certain distances from specified structure and material as shown in table 7. So bulk tank separation distances is 1 foot to building structure except wood frame. 5 property line. 10 feet park vehicle, sidewalk, structure openings, etc. So ayan yung mga ano niya. So bulk storage system consists of cryogenic tank that store liquid oxygen at low pressure. So this is 221 psi. Cryogenic tank are as back tank. Cryogenic tank are as unfired, double-walled, vacuum-insulated pressure vessel. Liquid oxygen has a boiling point of -297.3 Fahrenheit and a liquid density of 71.27 pounds per cubic foot. When vaporized into gas, it produces 900 times its liquid volume. Furthermore, since the tank is changed less often, process stability is maximized, and the introduction of atmospheric impurities is reduced. Tank systems are furnished with integral pressure relief valve vented to the atmosphere should the oxygen convert to a gas. Table 8 depicts currently available cryogenic tank capacities and Figure 2 illustrate typical bulk oxygen schematic. Ito yung mga volume ng tanke, liquid capacity, oxygen, size, cubic feet, and approximate weight vessel loaded with oxygen. So ito yung typical bulk supply system schematic. Okay. So this is the oxygen tank. Ito yung tank, ito yung reserve and accessories. So most bulk oxygen storage systems are furnished with vaporizer. Vaporizers are bank of tube exchangers that convert the liquid to its gaseous state. The vaporizers come in several sizes and styles, including atmospheric powered, forced air, steam, and electric, waste, heat, and hybrid. The selection of vaporizers should be based on demand, intermittent or continuous usage, energy cost, and temperature zone. Poorly ventilated sites or undersized heat exchanger can cause ice to form on vaporizers during the conversion process. An excessive ice formation can clog and damage the vaporizer. Also, ice could extremely cold gas or cryogenic liquid to enter the pipe system. So damage the bulb, alarms, and medical component, and even injure patient. Automatic controls furnished with the tank regulate the flow of liquid through the vaporizer. When there is a demand for oxygen, the supply system draws liquid from the bottom of cryogenic storage tank to the vaporizer, and then the gas moves to the final line regulator. Thus, a constant supply of oxygen at a regulated pressure is provided. So in case of mechanical difficulty or the depletion of liquid oxygen supply, the reserve supply will begin to feed into the distribution system automatically. An alarm signal should alert appropriate hospital personnel when the liquid in the oxygen storage tank reaches a predetermined level. The alarm signal should indicate low liquid levels, reserve in use, and reserve low. Next, cylinder manifold system. Compressed oxygen systems are comprised of cylinder manifolds that allow a primary supply source of oxygen cylinders to be in use, with an equal number of oxygen cylinders to be connected as a reserve supply. The controls of the cylinder manifold will automatically shift the flow of oxygen gas from the service side to the reverse side when the service side is depleted. Refer to figure 3 for typical oxygen manifold system schematic. So ito yung typical cylinder supply system without reserve supply schematic. So wala siyang lahat yan gamit. Note, supply system with different arrangement of valves and regulators are permissible if they provide equivalent safeguards. Level 1 system. Manifold system can be located indoors or outdoors. When manifolds are located indoors, the engineer should observe the following. A. Location. Preferably, the manifold should be in a dedicated room on an outside wall near a loading dock and have adequate ventilation and service convenience. Air compressor and vacuum pumps should be located separately from medical gas. So oxygen and nitrogen oxide cylinder storage enclosure. B. Adjacent areas. There should be no odors, vents, or other direct connection between the anesthetizing location or the storage location and any combustible agent. If locating near or adjacent to an elevated temperature area is unavoidable, the engineer should specify sufficient insulation to prevent cylinder overheating. Next, fire rating. The fire resistance rating of the room should be at least 1 hour. The ventilation, outside ventilation is required if the total amount of gas in rooms exceeds 3,000 cubic feet. Mechanical ventilation is required. Relief vent from manifold shall be piped to the outside. Security. The room or area must be provided with a door or gate that can be locked and leveled. Oxygen manifold are sized, taking into consideration the following. So the size of the cylinder. So table 9 for sizing charts. Hospitals usage of oxygen in cubic feet per liter per month. Here. So ito yung usage of oxygen. Depende sa pressure ng tank. So makikita nyo dito. This is based on 240 per cubic feet each cylinder. Ito yung cylinder, parang LPG tank. So yan. Ang volume na yan is yung volume naman nun na volume. Okay? So 6909. So 5856 divide mo ng 244, lalabas mo na 24. So this is 4 times ng cylinder stalled. So ibig sabihin, yung cylinder talaga is size good for 1 week. So every week, magre-replace ka. Okay? Hindi naman kasing ang dami-dami niya na yan. Okay? So iba kasing reference, ang size niya is good for 1 week. So dito, yung table na yan, ginimbo yan is for monthly, but the size of is mauubos ng dire-diretso is for 1 week. So next, nitrous oxide. The common source of nitrogen oxide is a cylinder manifold system. So high pressure manifold system consists of 2 banks of cylinder, primary and reserve. See the discussion under oxygen above. System demand for nitrous oxide can be more difficult to determine than they are for other medical gases. The number of surgeries scheduled, type and length of surgeries, and administering technique used by the anesthesiologist cause extreme variation in the amount of nitrous oxide used. Because of this variation, consideration must be given to the size of and selection of the nitrous oxide manifold. Avoid locating the nitrous oxide manifold outdoors and areas with extremely cold climate. Nitrous oxide is supplied liquefied at its vapor pressure of 745 psi at 70 Fahrenheit. So at extremely cold temperature, the cylinder pressure will drop dramatically to a point where it is impossible to maintain an adequate line pressure. This is due to a lack of heat for vaporization. For nitrous oxide manifold located indoor, the same precaution previously listed for oxygen system must be observed. Central supply system for nitrous oxide and carbon dioxide using cylinders or portable container shall be prevented from reaching temperature lower than 20 Fahrenheit and higher than 130 Fahrenheit. Kaya may ventilation. So the following should be considered when selecting and sizing nitrous oxide manifold in determining the number of cylinders required. A. Size of cylinders, table 10. B. Number of anesthetizing location or operating room. So, andyan. So, number of operating room. So, andyan yung mga cylinder. So, for provide 1/2 of 1 cylinder per operating room for in-service and reserve supplies as a note. 1/2 of 1 cylinder. So, ibig sabihin, total, so cylinder per side. So, dito, sinasabi dito is provide 1/2 of 1 cylinder per operating room for in-service and reserve supplies. So, dalawa siya. Both side. Isang reserve, dalawang in-service. Okay. Medical compressed air. Medical, surgical, low pressure compressed air at about 55 psi gauge, 379 kilopascal, and high pressure instrument air, 200 psi gauge, are usually supplied from air compressor. So in facilities that require less volume, a manifold system may be provided. The manifold system for compressed air are similar in configuration to those for oxygen and nitrous oxide. Air supplied from the cylinder or that has been reconstituted from oxygen, USP, and nitrogen and must comply at minimum with grade D and ANSI CGA G7.1 commodity specification of air. So check na lang yan. Medical compressed air produced by compressor may be defined as outside air atmospheric to which no contaminant in the form of particulate matter, odor, oil, vapor, other gases have been added by the compressor system. It must comply with NFPA 99 and or the Canadian Standard Association's air quality standard. Air compressed for medical breathing purposes is to be used for this purpose only. It should not be used for other application or cross-connected with other compressor system. So, yan yung air compressor. So, not every compressor is suitable for use as a source for medical compressed air system. Compressed air in healthcare facilities. Only those compressor units specifically designed and manufactured for medical purposes should be considered as a reliable source of oil-free, moisture-free, and low-temperature compressed air. Three major types of medical air compressor are on the marketplace today: centrifugal, reciprocating, and rotary. The reciprocating and rotary are positive displacement unit, while the centrifugal compressor is a dynamic compressor. The medical air compressor shall be designed to prevent the introduction of contaminant or liquid in the pipeline by one of the two methods. The type 1 air compressor eliminate oil anywhere in the compressor, while type 2 compressor separate the oil containing section from the compression chamber. Examples of type 1 compressor are the liquid ring, rotary screw, and permanently sealed bearing compressor. Type 2 compressor have extended heads. A positive displacement compressor is rated in actual cubic feet per minute, ACFM. This is the amount of air taken from the atmospheric condition that the unit will deliver at its discharge. So within a broad range, changes in inlet air temperature, pressure, and humidity do not change the ACFM rating of the either the reciprocating or the rotary screw compressor kasi based ito sa pressure and temperature ng discharge. So the centrifugal compressor capacity, however, is affected slightly by the inlet air conditions due to the nature of compression process. For example, as the air temperature decreases, the capacity of dynamic compressor will decrease. The capacity of the centrifugal compressor is defined in inlet cubic feet per minute, ICFM, yung actual inlet pressure and temperature. In an effort to obtain an apples-to-apples comparison of various compressors, many manufacturers specified their capacity requirement in standard cubic feet per minute based on standard pressure and temperature. This sometimes causes much confusion because many people do not fully understand how to convert ECFM or ICFM to ECFM. Figure 4. So design engineer specifying ECFM must define a typical inlet air condition at the building site in a set of standard conditions. Typically, 14.7 psi A at 60 Fahrenheit standard and 0% relative humidity. The warmest normal condition open is specified because ECFM decreases as the temperature increases. This is the conversion table graph. So may formula naman yan na ideal gas. So in case of dynamic compressor, the ICFM airflow at the given inlet condition is inserted in place of ECFM. Another design issue that the engineer should be aware of is how altitude affect the output of the compressor. Yeah. Altitudes above sea level, all medical air systems have reduced flow. In these cases, the required sizing will need to be adjusted to compensate. To do this, multiply the ECFM by the correction factor in table 11. Yan. Ito yung correction factor. In other words, to correctly size the medical air system, apply the corrector factor listed in table 11 to the peak calculated ECFM at sea level. Example, a facility is located at 5,000 feet above sea level and the system demand is 29.4. What is the adjusted ECFM? So 29.4 by 1.08, the correction factor for table 11 to get the adjusted ECFM requirements of 31.8 ECFM at 5,000 feet above sea level. As this example shows, a medical air system of greater capacity is needed at high altitude. So another handy formula for compressed air system is the following. To convert ECFM to liter per minute, multiply the ECFM by 28.3165. So each compressor must be capable of maintaining 100% of the medical air peak demand, regardless of the standard compressor operating status. Where more than 2 units are provided for a facility, any 2 units must be capable of supplying the peak calculated demand. Refer back to table 2. So provide automatic alternator duty cycling controls to ensure even wear and normal usage. Pareha sila yung wearing niya. Alternator controls incorporate a positive means of automatically activating the additional unit or unit should be the in-service pump fail to maintain the minimum required pressure. The basic compressor package consists of filter intakes, duplex compressor, aftercooler, receiving tank, air dryer, inline filters, regulators, dew point monitors, and valve. The compressor components are connected by piping that allow equipment isolation, provides pressure relief, and removes condensate from receiver. So figure 5 for typical arrangement of medical air compressor. Yeah. Analyze yung diagram. So the compressor air intake should be located outside above the roof level at a minimum distance of 10 feet from any door, window, exhaust, other intake or opening in the building. So typical naman to. So and a minimum distance of 20 feet above the ground. So refer to NFPA 99 for the proper location of medical air intakes. The compressor shall draw air from a source of clean air located where no contamination is anticipated from engine exhaust, fuel storage vents, medical surgical vacuum system discharge, particulate matter, or odor of any type. Beware of gases from boilers and gas-fired water heater as they are a common source of problem with medical air intakes. Where the outside atmospheric air is polluted, special filters can be attached to the compressor intake to remove carbon monoxide and other contaminants. Table 12 provide the minimum pipe size for medical air compressor intake risers. Consult with the compressor manufacturer on intake recommendation and allowable pressure loss for the intake riser before finalizing the pipe size equipment selection.